how an executive oversees a software team here on Programming with Palermo.
You are programming with Palermo. You deliver software. You need to move fast, deliver quality, and run your software with confidence. Stay tuned for timeless solutions, simple methods, and topics that will propel you forward. And now your host, lifelong programmer, author, teacher, coach, Christian, and charismatic speaker, Jeffrey Palermo.
Welcome back to Programming with Palermo. I am Jeffrey Palermo, your host, and thank you for being with me. Today, we have something to talk about just for the software executives, or maybe even the CEO and owner of a company, the executives that oversee a software team in their organization. The executive that might not even have ever programmed before, but has to budget for and oversee a software team with some really important software projects. That's what we're going to get into today. Our industry struggles mightily with failed software projects. On average, half of projects still fail, and failure is defined as the executive who authorized the budget wishing that he hadn't. The project is so over budget in this case and so over schedule that the company would have been better off having never even started it. And even in the middle of these projects, executives can feel powerless to abort it for fear of the sunken costs. They've already put so much money into it. And without knowing the right questions to ask or the right reports to demand, the executive in charge doesn't feel in charge at all. And he's left choosing between just trusting the team, still longer as it goes on, or perhaps exercising a nuclear option to just can and fire the entire team and cancel the entire project and just have nothing to show for it. Now, right now, if you're an executive overseeing a software group, I want to equip you with the tools to do that well. And if you work on a software team, in the software team, go ahead and use this advice that I'm giving you here to give your software executive the information that he needs to know to know that the project is on track, and or the insight to know that the team needs to do what the team needs in order to do a good job. Now, from here out, though, I'll call you the software executive, all right? Even though maybe some of you have never programmed any code before in your life, you are running a software team. Their success is going to steer your future career. And so this is important. Don't keep going on faith. Don't proceed, just keep on going down the path, merely trusting that someone is going to do the right job, that someone else reporting to you knows how to do your oversight job for you. Lean in, and I'm going to give you the questions to ask, the tools to use, and the practices to deploy so that you can safely guide your software project to success. And most importantly, if your current software project is veering towards failure, I'm going to empower you to stop the bleeding and get it back on track. All right. Before diving into this guidance, I want to paint a mental picture, get a mental model for you. Think of every other department in the company. Think of every group. Think of every team, every branch of the org chart. Each one of them is responsible for delivering some output valuable to the business. And each of these teams also needs some inputs in order to deliver those results. And if the outputs are not delivered, the team's leader is typically replaced. It's just how it goes. And the leaders who excel are the ones that can set up the team members for success.
Programming with Palermo is brought to you by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient, moving fast, delivering quality, and running their software with confidence in Azure. If your team has a project that's too important to be delayed or derailed, ClearMeasure can help while keeping your team in the driver's seat and growing in capability. Click on clearmeasure.com for more information. If you are an architect or .NET engineer aspiring to become an architect, check out clearmeasure.com/careers. Now, back to the show.
All right, let's look at this mental model. All right, imagine a factory is arranged well and operates efficiently every single day in a safe manner. The assembly line flows at a good speed with incoming materials being delivered at the right cadence, to keep it going. Quality issues are prevented and possible ones are detected very early. Hourly and daily throughput measures are tallied and reported up the management chain. Quality and throughput measures are paired with acceptable thresholds and established as a standard with better numbers as stretch targets. Okay. Then the executive in charge ensures that the factory or assembly line is organized in a way where each team member understands the job and what activities they're going to take to meet the targets. What we don't do is declare a building to be the manufacturing plant and then just ask the team to come to work inside it one day and then come back and check a month later. The people we staff on the team are typically not the same people needed in order to design the process for how the team should work. Factory would never work that way. And in software, Scrum has done the industry a big disservice by spreading the notion of self-organizing teams as an absolute. Even the certified Scrum Masters are trained to ask the team what they want to do and then work to remove blocking issues. That's highly simplified, I know, but I've been certified as a certified Scrum Master. So I've been through it earlier in my career. And the Scrum Master works to remove blocking issues to get the team down the road. This isn't leadership. Only when a team is working in an efficient manner can the lower level details be turned over for self-organization. An appropriate leader, that's you, is always necessary to put the overall structure in place for the team so that real measurable throughput can build momentum. I've started out with that factory and assembly line analogy, and many knowledge workers will rightfully object that the nature of work in software is different. And it is. Earlier in my career, I was one of the self-organization promoters, and I was banging the drum about knowledge work being unestimatable or unmeasurable. But speaking for myself, what I liked most about that message was that it gave me space to dive into the work without having to report up as much. It gives me more space as a programmer. But what it didn't produce was less risk for the executive who authorized the project budget in the first place. So this challenge exists in all the fields of knowledge work as well. Managerial, accounting, and CPAs, they also have tough problems that don't have just rote solutions. Rote solutions have really been automated away by good accounting software. But if your CPA takes forever to figure something out and then bills you twice as much as you budgeted, then you still have a problem. Sales is also another area that has some similarities between the quote magic of software development. You want a certain pace of sales, and the staff just want to get to work. They want to start selling. But seasoned sales executives who are overseeing the sales team, they know that without a good sales team process, the closed sales are not going to happen. And even enterprise sales can take 3 to 6 months or longer. They just don't ride on the quote trust me message from the sales rep. Good sales executives, good sales executive leaders put in place processes with measures, like the number of leads contacted, the number of meetings, the number of emails, phone calls, networking events, and the like. My goal in this introduction is to suggest that we dispense with any notion that software is too complex to be managed like other departments in the business. I've been managing programmers for 17 years and was an individual programmer long before that. All we have to do is raise up the conversation from the technical jargon, and we can get to a place of business language where all the executive tools still apply. Whether you like to use OKRs or the EOS L10 meetings with a scorecard or just regular weekly metrics, you can apply the oversight methods of your other teams and your executive peers. You can apply those to your software team. So let's get into it. The first thing we need to talk about is team alignment. Before we discuss software specific issues, let's apply what we already know about team formation and team alignment. Okay. If any team is going to be high performing, it has to be aligned and going in the right direction. The old model of forming, storming, norming, and then performing applies just as well to the software team. And the Clear Measure Ways team alignment template provides a form to document the team's alignment. And just like other parts of the company, without consistently reinforcing the vision for the project and the business strategy, okay, on top of that, after all, the business strategy caused a software project to be commissioned in the first place. Without that, a team is going to stray. It's human nature. It has nothing to do with software. And regardless of what information is chosen, the team has to send a periodic report to you, the software executive. After all, you're giving a report to your executive team or board of directors. And if you have no report from the team, then it's hard to do your briefing. So you need some form of scorecard. The Clear Measure Way curriculum also includes a software team scorecard template that you can use. And we suggest the minimum set of measures to report. Now, as time goes on, you're going to want to add more and more measures. That's normal. You do that in every other team. But within that, we need to make sure that you have the right team skills. Just like any other team in the business, if your software team doesn't have the skills needed to execute a particular project, then you're not going to succeed. But if you haven't cataloged the required skills that you need, or maybe taken an inventory of the current skills that your team has, then you just don't know. And one of the peculiar traits of many software developers is their inventor personality. If you ask them, quote, can you do fill in the blank? Can you do this? Well, they're going to answer, yes, I could do that. Even when maybe they've never done it before. I've certainly done that in my career. They'll tell you that they can. And after all, Orville and Wilbur Wright said that they could make a flying machine. They never had in their life, but turns out they did. But that process was invention, not implementation. And developers like to invent, and developers are pretty good at inventing. But it's a difference between can you, as in you've never done it before, but you'll figure it out, from you've done it before, you actually have the skill, versus you have confidence that you can get the skill. So you need to know what your team members have done before, not what they believe they can learn to do. If you have a smartphone app project maybe in front of you, but no one has ever put a smartphone app into production before, then you're missing a skill. It's not a bad thing. It's just a fact. This is just one example, but you can see again that any department in your business goes through the same skills planning. If your accounting department doesn't have anyone who's ever done inventory accounting for large warehouses, for example, and maybe you intend to build a warehouse, then you need to recognize this and augment the accounting team. There's no such thing, by the way, as a full stack developer. Oh, you'll find that term on the job boards, but quote, full stack, well, it means very different things to different people. It depends on the technology stack. So if someone places, quote, full stack developer on their resume, you have to look at the projects they've done, which constrains their definition of stack. Also, some skills represent answers to strategic risks for you. Let's take security. Security breaches can tank entire lines of business. This is just not some technical skill that somebody has. It's a department competency. Okay. So I encourage you to get specific in needed skills and current skills so that you can understand the actual skills that you have and the ones that are lacking. And then you can build a training and staffing plan for your project. Chances are some of your existing people can do some training and add some skills. You invariably have smart people that can do that. And then there's going to be other skills that need to be sourced from the outside, either, on a maybe temporary basis or with another permanent hire. All right, let's switch gears and progress down to quality. Establishing quality. We all want our team to be able to move fast and deliver at a rapid pace. But from an oversight perspective, you as the software executive need to demand a quality output from them. And this isn't just slamming your fist on the table and say, give me quality, but you need to demand a quality output from them at whatever pace they can deliver first. Measure the pace that they're delivering first with a certain quality. with a good quality that you can that you can be happy with. Think of when you were learning to type. The measure of typing speed is the number of words per minute with some number of errors. With maybe 100 words per minute with 100 errors. Well, that doesn't do anyone any good because that doesn't represent 100 typed words. It represents 100 misspelled words that have to be fixed. You want 100 words per minute with 0 errors. Okay. Capers Jones, in his writing about software metrics, notes that teams who prioritize productivity think of quality as something to balance, and they end up suffering with poor quality. And then with bugs mounting up more and more, you end up spending a lot more capacity of the software team to fix the bugs, and with less of the team's full capacity going to delivering features. When you get in that situation, productivity slows down, creating more pressure to reestablish productivity. And the team members then under even more pressure to perform, take more shortcuts in order to get things done. But this just yields more bugs, which takes more team capacity to tackle. And with a small fraction of the overall team capacity then dedicated to new features, the overall productivity tanks. And over time, this is the cause for some teams to pitch a new plan to management. They'll say, we need to modernize this system. Well, that is just code for, quote, fixing this is more effort than starting over from scratch. This is the equivalent to waving the white flag and surrendering. No army that surrenders can later claim victory. As the software executive, this is where your leadership comes in. Sequence the establishment of a quality standard first, before challenging the team to increase the pace of delivery. Then measure the number of bugs caught before production and the number of bugs caught by users in production. Measure how long it takes to fix each bug. All of the modern work tracking tools, by the way, they'll do this well for you. That's really good tools these days. And this is the easy part. Your leadership is important here because you're establishing a principle, an important principle for your team to abide by. And that principle is that quality should be prioritized over speed of delivery. Because you know that adopting a speed over quality strategy doesn't yield you either speed or quality. In your weekly team meetings, which every team should have, ask the same question over and over. Same question. Say, tell me about that bug that escaped into production. What are we changing so that kind of bug can never happen again? Their answers are going to be different every time, but your question will be the same. You can also ask for a tour of the code that caused the bug. If you can't understand the explanation or the code, then you found a quality hotspot that you'll want to ask more questions about. Don't believe the lie that, the code is too complex for you to understand. After all, you wouldn't accept that excuse from an electrician or any other trade. That's how you got to be an executive. You can kind of see through and you can raise up and simplify. After all, in this situation, the purpose, and everyone needs to understand, the purpose of the software is to simplify a domain that has a higher complexity without the software. And in any of the teams that you oversee, you'll want to understand the engineering practices that are in place. Here's a few that every software team should be using. Test-driven development is one. Continuous integration, static analysis, pull request checklists. By the way, that's a good modern implementation of a formal change inspection. That's kind of been around the industry for a long time. Minimum set of practices. I expect the team to have other practices in place as well. They all do. And these practices ensure that quality is kept to a high bar. And without these, your team is going to struggle just unnecessarily to keep quality high, especially on a multi-developer team. Okay. Now, we're not talking about small little dinky code projects that a single person can do. If you get somebody that has a good experience and smart, a single person can do a small project, but we're not talking about those. We're talking about more complex projects and you have a multi-developer team, you have to have stronger structure and stronger practices. Okay, so establishing quality, super important. Let's go on to the next pillar in the clear measure way, which is achieving stability. Now, once a team has the practices in place that enable code to be delivered that's free from defects and bugs, the next priority is to get that code into production, into a production environment in a stable fashion. Now, chances are that you don't just have a new piece of software um, and that's all you have. You have existing pieces of software in production that have some stability issues from time to time. Stability issues can have one or more, maybe of these common symptoms. Sluggishness is common. Outages, or maybe it goes offline. Error messages or frozen screens. Abnormal behavior or bugs that can't be reproduced by engineers. They only happen in production. When the users report any of these symptoms, then you have a production issue. And having a good language around these symptoms gives you clarity in your oversight duties. Remember, you're the software executive. You got to oversee all of this. And you want to make sure that the appropriate stability measures are in place to track the stability. If the software is not stable, it's not going to do its job. So you need to ensure the stability of your software as it runs in production. Now, sometimes teams can be a little gun shy of production deployments. They might sometimes advocate for monthly deployments or maybe after hours deployment events with everybody, all hands on deck. And this is technically unnecessary, but is commonly born from a previous unpleasant experience making changes to a production environment. They're gun shy. They've been shot before. After a deployment goes bad, developers can really become hesitant. They can become wary and distrustful of the process because they consider it dangerous. They've experienced it being dangerous. But a large inventory of undeployed software, well, that's not only a big investment that isn't generating any return from the business, it's also a growing risk of unproven software changes. Now, let's think about other departments again. All departments that manage throughput understand the power of limiting work in process, WIP. Infrequent deployments queue up way too many changes that are waiting for a big, stressful, error-prone deployment event. Now, ultimately, your two goals to achieve stability are to, one, prevent production issues, and two, minimize undeployed software. In other words, get the software out there so it can start yielding the business a return on the investment you've made in it. And you can measure these on the team's scorecard with tracking weekly metrics. All right. Metric number one, number of deployments for the week. It's just a number. Metric number two, number of production issues for the week. And of course, you want to divide these by severity, whether it's Sev 1, the system's completely down, versus 2, 3, 4, whatever categorization you use. And then you also want to measure MTTR. That's the mean time to recovery, or average time to resolve the issue. Now, as with overseeing the bugs on the quality side, you can ask your team the same questions to drive the right behavior. You can ask, hey, what features or changes are tested and ready for production? Then you can ask, hey, what was the root cause of that production issue? And what are we changing so that this type of issue can never happen again? Or you could ask, hey, what should we strengthen about our environment so that we're able to resolve issues faster next time? Okay, that's just some sample questions. And also, as with quality, there's a minimum set of practices that every team should employ if you have the expectation of running a stable software system in a production environment. All right, let's just go over the minimum. First, automated DevOps from day one of a new project. And the goal of that is to eliminate manual monthly deployments. You want to have automated deployments all the way from code, builds, test, release candidates, deployment. All right. Second, you want to have small releases, not big releases, small releases. You want to be able to deploy when something is ready, whenever, whatever time of day. Okay. Third, you want runtime automated health checks. That's think of a car having a built-in self-diagnostic that you plug something into the car and it tells you the error codes. Okay. You want to have a built-in health check. Then four, you want to have explicit secrets management because security is such an ongoing risk and attacks are happening all the time. And that's just the minimum. There's going to be other practices to prevent issues. When a production when production issues start to crop up, if you have issues in production that are happening over and over again, they will from time to time. The following practices are going to enable the team to diagnose them quicker and come to resolution. All right, so let's go over those practices. One, centralized open telemetry logging and also metrics and traces. Okay. If you don't have centralized telemetry, look into that. The great standard open telemetry that kind of all the tool vendors are using. It's great. Second, an APM, which stands for Application Performance Management, an APM tool with a shared operations dashboard. Third, a formal support desk tool with ticket tracking, anomaly alerts, and emergency alarms. Okay. All right. Now, if some of this sounded familiar, it's because many of them are the software parallel of practices to operate any other factory or assembly line in a factory. If a part of a production line experiences an issue, it's an obvious alert with staff springing into action to resolve that problem locally before it becomes a factory outage. And for more serious problems, emergency alarms just stop the line and call everyone's attention to rally around the problem and get the production line up and functioning again. And while the tools are different, the way of thinking is the same. So here's some questions to ask your team in order to gain insight into how these may or may not be implemented. You can ask, hey, would you please give me a tour of our logs and telemetry that allow me to see, how the users are using our software, what they're doing? Or you could ask, how do we currently train a new team member to be on call for production support? And what dashboards should they be looking at to ensure the software is functioning in a stable fashion? Or you could also ask, what events currently trigger an alert and what events currently trigger an emergency alarm? Okay. Who receives the alerts and how? How do we all receive the alarms? Okay. Ask those questions. All right. So that's stability. Now let's talk about increasing speed of delivery, which is productivity. Okay. All right. So as we turn our attention to increasing speed, let's go over a few things. And by the way, this is quite a bit of information to digest, before we talk about productivity, because we've gone through a lot of things and we're just now getting into productivity, but really for good reason. With quality problems, our team is diverted to diagnosing and fixing the bugs rather than working on new changes and features. And with stability problems, our team is yet again distracted from actually working on new changes because the production environment rightly takes priority. And even if we staff dedicated systems engineers to be responsible for supporting the production environment, they typically can only operate a stable system. For high-scale systems, it's normal to constantly be changing the number of servers or cloud CPUs or Kubernetes pods based on the load. And it's normal to be watching the queue length as data flows to be able to be sure that those messages are being processed within the established SLAs. But when errors are happening and when the system is not behaving as the systems engineers have been trained to expect it to behave, then those issues are just escalated back up to the software team. And this is where development capacity goes. The power of prioritizing quality and stability first is that the result is 100% of your team's capacity actually goes to the new work set before it. And with this as an achievement, then we can look at what then causes the team to be able to move fast when it's actually able to work on new software changes. From an oversight perspective, I'd like to paint a picture of how to think about your team's productivity, or say throughput or pace. So let's take an analogy of the Baja 1000 desert race. To do well in this race, you need to finish. That means you need to pick a pace that will not cause your drivers or your machine to expire, to break down. And then you need to navigate it well. If your drivers get lost or go off course, uh, you know, they may drive many more miles than necessary, run out of fuel. So picking a good course and staying on that course shortens the miles necessary to finish the race. And even so, an obstacle may emerge and likely will emerge that needs to change the course they're traveling on because of new information that they learn while driving. And finally, the drivers must drive fast along the chosen route. Now let's apply this analogy to the software team. The team alignment template has given us a tool to ensure everyone is clear on where we're going, and that is what business outcome we want to achieve. This is the finish line. Feature A or feature B is not a finish line. Any individual feature is akin to a particular route on the race course. And we're choosing feature A because we reasonably believe that changing the software in this way will push us towards our chosen objective. But as we move along, we need to watch out for new information that would help us learn that maybe feature A might not be the progress toward our objective that we hoped it would be. Okay. So let's pause now and tackle a fallacy that's been promoted heavily in our industry. And that fallacy is that of the product owner. The Scrum curriculum heavily touted the product owner as the role that knew the customer so well that he was the one. Only he was the one to prioritize the backlog with items in the correct order. And because the product owner had prioritized them, these features were deemed to be the right software changes to make. In practice, so few teams have been able to find a person with that good of customer knowledge that the role of product owner hasn't worked for our industry. The 2018 State of DevOps report by Puppet Labs shared a study that teams using product owners had a batting average of about 1/3, 333. And in other words, the product owner was right about 1/3 of the time. When the changes were put into production, they yielded the desired outcome that was wanted. What's interesting is that another 1/3 of the time, the changes put into production yielded no progress towards the desired business objective. And the final 1/3 of the changes actually hurt performance of the software and moved the business away from its objective. These changes had to be hurriedly backed out. Okay, they were hurting things. Now, in your oversight role, don't rely on anyone to be so prescient that you trust them implicitly to decide what changes to prioritize. Instead, think about it like any other department in the company. Measure the result and adjust based on the actual data that you collect. And this is another reason for prioritizing stability ahead of moving faster. The same practices that achieve stability yield a capability for collecting data used in business analysis for what features yield a desired result. Now that we have a good mental model for how to increase speed towards a goal, we need to measure the current actual speed. All right. You'll want to add more measures to the team's scorecard, add weekly numbers that represent progress towards the business objective of the software. And if the software is related to, say, e-commerce, you may add daily revenue. If it's an inventory system, then you may add numbers that are reported on executive team scorecards around inventory and warehousing. This gives your software team ownership of targets that other executives see that are important outside the software team, important for the business. And then they can participate more fully in improving those business measures. So when it comes to software specific measures for the scorecard, I do suggest these as a minimum. First, desired number of issues delivered per week. Next, current number of issues that are being delivered this week. Next, the average time an issue spends in each of the statuses. Okay, that's progress. Now, if you're just starting this type of measurement, you might not know what target to set for the desired number of issues delivered per week. That's fine. Go ahead and defer that until you've measured actuals for probably about a month. An important principle on which these measures are dependent is commonality. Okay. Now, let me give you another example. The shipping industry is able to deliver any size or shape of object to a destination. And this is because they have packaging standards. There's envelopes, there's small boxes, there's long tubes, there's pallets, and even shipping containers. And in software, no two features are the same either. But yet the shipping industry has figured out how to send ships with just a bunch of shipping containers. So at the ship level, they don't care what size they are. Now, in previous decades, and still today, software teams have attempted to treat every software as unique and then estimate. And they've tried different methods of estimation to get to numbers that could actually be relied on to figure out how much work was in the backlog. But no method of estimation today has actually succeeded and reached that goal. And let's take an example. If our work tracking system has some features in it that are 10 times or 5 times or 2 times the size of other smaller features, then it's hard to get the team into a flow of consistent delivery. And again, other departments that measure throughput know that the work needs to be made common size in order to empower the team to shine and deliver at an increased rate. In software, the practice to embrace is feature decomposition. In project management, there's a practice of work breakdown structure. Breaking down units of work into smaller tasks is used widely elsewhere to make the work more approachable as well as manageable. Feature decomposition is the work breakdown structure in software. So guide the team to break down software changes into tasks that can each be reasonably completed in one day of effort. For some features, you're going to be challenging the intended design in order to accomplish this. The result will be development tasks that are all roughly 1 day of work in the size of labor. Okay. And with a common sized unit of work, you can measure the throughput of your team. But measuring throughput isn't the only reason for doing this. Large software changes that are not broken down are typically where other problems exist. Faulty analysis, undefined architecture, incorrect assumptions, and undiscovered unknowns. Breaking down development work ends up exposing those hidden problems and further increases quality of what is delivered. Breaking down the work forces more design work upstream of the coding activity because design decisions will have to be made before initial code is written. Starting writing the code on a feature that's already too large, it mixes missed analysis and design conversations right in the middle of unfinished code when the developer gets to a point where he finds an unanswered question. Then he has to stop coding, take hands off the keyboard, and then have an impromptu meeting that has to happen right then because coding on that feature is now blocked. And you can safely assume that a feature or change that is expected to take several days to complete will not take several days. It'll take 2 times that, or 5 times that, or 10 times longer than that. The several days estimate, that's really just an estimate of no confidence. Only when you have an estimate of 1 day can you be certain that all needed work has actually been identified and understood well. And in this process, you'll also see more detailed design diagrams since more knowledge will be flowing throughout the team. And as you increase the team's delivery speed, here are some minimum practices to expect to have implemented. A Kanban style work tracking board. That's a work board where items move from left to right. Next, feature decomposition or work breakdown structure. Third, design diagrams for everything. And then fourth, refactoring. Now the last item on the list, refactoring, that's a mature practice. You can find some good books on this practice, and it recognizes the reality that since we're going to learn from how our users use the software after the software has been built, then we need to expect more changes based on that learning. Refactoring is our method for making those changes. And we're going to learn that, say, a feature should behave and be designed differently once it's in production. Refactoring is a means by which we change the software so that the feature becomes designed in a new way, as if we had been designing it that way from the start. And here's a suggested question to ask for when you learn something new from users in production. So, since we need to change feature A, what parts need to change? What parts in the software need to change so that the outcome is as if we had intended to design it this way from the start? Now, the lack of refactoring that happens, it will compound over time into a code base that is hard to understand and hard to follow. Refactoring ensures that the code is always easy to understand at a glance. And as you measure your team each week, look for the current number of issues delivered each week to increase. You'll also notice bottlenecks to increased speed on your Kanban style board because you're measuring the average time an item takes in each of the statuses on your work tracking board. And when bottlenecks are discovered, you resolve them. The lack of tracking time per status, if you don't do it now, that's what allows bottlenecks to stay hidden. Okay, with all this, you have a very strong oversight position and responsibility for your software team. It'll be important to keep quality, stability, and speed in the proper order. Okay. Schedule pressures, they can tempt teams to forget about this order, to allow quality and stability to slip by, tolerating shortcuts, taking shortcuts. Okay. But it doesn't take long for shortcuts to accumulate, resulting again in poor delivery speed. Like whenever a bug makes it out to users or whenever production issues happen, reinforce to the team the importance of taking action so that this kind of bug or issue can never happen again. It's a logic journey. For a bug or issue to not happen again, it's not just about the team trying harder or gritting their teeth tighter. It's about real root cause analysis and changing the problem at the root so that it's impossible for the bug or production issue to happen in that way again. Okay? That's the way to be thinking. Okay, let's finish out with leading and strengthening the team. While you're enjoying your high-performing team, stay vigilant. Recognize when you need to go back and redo some of the parts of the process. When you add a person to the team, when a person leaves the team, back up to skills assessment and skills inventory. Review the team alignment template. Allow the now changed team to form again, storm again, norm again, so that they can perform again. Keep them equipped. Make sure that every member of your team has an avenue for ongoing professional development. Keep measuring the team. After all, A players look forward to the report card. Create an environment where A players can celebrate. Your less than A players will probably self-select themselves out. But when you identify a B player, craft a professional development plan with them so that they become an A player. Your A players want to work with other A players. And they want to work in an area where it's normal to succeed. The working environment that you've crafted for them is going to empower them to succeed, and they won't want to work anywhere else. You will have crafted a team with longevity that has established quality, achieved stability, and is increasing its speed of delivery each day. So to conclude, I just want to tell you, you have what it takes to oversee your team as a software executive. You can do it. By implementing these principles, leading your team with a scorecard of relevant measures, and putting into place these team practices, you will have a team that is an asset to your business. I know you can do it, and we're here to guide. May God grant you wisdom as you lead your team. Thanks for joining me again on Programming with Palermo. This has been a video just for software executives as an audience. If you are a software executive, I hope it was useful, or maybe you know an executive who has a custom software team in their organization. Go ahead and share this video with them, and I hope it'll bless them. Thanks for being with me. God bless.
You've been watching Programming with Palermo, your primary place for highly productive programming protocols and practices. Remember, you have what it takes. You can do this. You are a programmer. formed by God Himself and called to this profession for a purpose. You can catch every episode at Palermo.network as well as syndicated locations nationwide. We're so glad you tuned in. Until next time, may God bless you, and thanks for programming with Palermo. Programming with Palermo has made a special arrangement with Marketplace Chaplains. Besides programming challenges, we all face issues in life where we need some help. If you'd like, you can call a chaplain confidentially. To speak with a gentleman, dial 512-923-8178. Or to speak with a lady, dial 512-619-6950. The show won't know you called, and everything is kept in strict secrecy. This is a free service, available if you or a friend need it.